So the first thing is inverse trig. So last semester when we were doing derivatives, we had inverse derivatives, right? Those were the last ones on your sheet, on the back of your neon sheet. Okay. Today we're going to do the opposite. We're going to do inverse trig, but for antiderivatives. Okay? Luckily, there's only 3 of them, 16, 17, and 18. The others you don't have to worry about. Okay? For inverse trig, when you're doing derivatives, you had, remember arc and inverse are the same thing. So if it says arc sine, it really just means inverse. Sine, cosine, tangent, cotangent, secant, cosecant. For all those we had for derivatives, right? For antiderivatives, we just have to worry about 3. Inverse sine, inverse tangent, inverse secant. Okay, that's the only 3 that we have. So that's the 3 that I have at the top of the list. Okay, those are the 3 that I have on top of the list. So the hardest part about these is realizing that they fall into this category. This is not hard, but sometimes you just don't realize it, okay? Because of like letter A, 1A, you're trying to do this on a test and you're trying to figure out, okay, so how do I do antiderivatives with this? Is it U substitution? This one won't work for U substitution. You can try this with U substitution, but it won't work, okay? It won't work. The reason is, it's one of these guys, all right? So which one does this fit the best? Sine, tangent, or secant? Sine. If it fits sine, the easiest, right? What's the easiest way to tell? It's got a root underneath, so it's not going to be tangent, right? And doesn't have a number in front of the root. Doesn't have anything in front of the root, right? So it's going to be sine. Sorry, inverse sine. So the first thing we got to do is label what's what. Okay, label what's what. So the first thing is we're going to have a U and we're going to have an A. An A and a U, right? Because that's what it says up here.
What about DU?
DU is just dx. Okay. So what would be A?
1.
1. What would be U?
X.
It would be x, right? Not x squared, it would be x, because the squared's already there. So I'm going to rewrite it to make it look like the top one. Okay? So we have 1, 1/2. 2's on top. Okay. Then we have square root, and then I have a squared minus u squared. Oops, not 0, or sorry, not 1. It's x. All right, dx. Okay? So once we know that, so the 2, what I'm going to do with the 2 is I'm going to move it to the front. I'm going to move the 2 to the front. So 2's out in front, 1, 1/2. I have 1, or you can put dx on top of there. Square root 1/2, or sorry, 1 squared minus x squared. Okay. So what does that equal? Well, that equals arc sine or inverse sine. You can write arc sine, you can write inverse sine, it doesn't matter. So we have the 2 in front times arc sine u over a. Well, u in this case was x, a was 1, and we're not going to do a plus c for this one because this one has bounds. So we're going to evaluate it from 1 to 1/2. Okay. So that means I'm going to plug in the top bound I'm going to plug in the bottom bound, just like we did last week, and I'm going to subtract them. So 2 times arc sine, or inverse sine, of 1. 2 times arc sine, or inverse sine, of 1/2. Okay?
Do you use radians or degrees?
Radians. So we're going to use, yeah. Unless they tell us specifically, almost all the time in this class we use radians, yeah. So what's the difference? So let me ask you a different question. I think I asked you this question last semester, but it's a while ago. What's the difference between inverse trig and regular trig? So let me give you an example. Like, what's the difference between, if I say sine of something versus arc sine of something? What's the difference?
Flip.
Something's flipped. What is flipped? No, not that. Something's flipped, though. You're right. Something is flipped. No. What's the difference between, if I say sine of something versus arc sine of something? What's the difference?
Sine is being divided by sine, isn't it?
Not division. The x and y values. And for sine, what does x represent? A degree, an angle, right? An angle. It represents an angle. And it's asking you for the ratio. The ratio is what's on your table. The ratio is these guys. These guys are the ratios. All the guys in the middle. Those are all ratios, right? So when I ask you a regular sine problem, I'm saying, here's the angle, what's the ratio? So you go, oh, okay, so sine of pi over 6 is 1/2. Those kind of things, right? Arc sine flips it and says, here's the ratio. What's the angle? Okay? So when I say arc sine of 1, I'm not saying 1 is the angle. I'm saying 1 is the answer. 1 is the ratio. What angle gives me sine of 1? Would give me a ratio of 1. So we're kind of going opposite. So pi over 2, right? Pi over 2 is where I would get sine of 1, right? So the angle is your answer this time. So the angle is going to be pi over 2. Right? Instead of saying what's sine of pi over 2 like you're used to seeing, that's 1. They're asking it reverse. They're saying, where is the answer going to be 1? Pi over 2. Okay? That's what arc sine and arc tangent and arc all, that's the only difference. They're just reversing it. Okay?
So if it's asking for the angle, it still wouldn't be 90 degrees because we're using the...
So asking for the angle. No, we could use angle. We could use, this okay. For this, yeah, that's okay.
Mr. Flores, does it matter which one we use because there's multiple of them?
So yeah, so sometimes there's multiple answers. So this one says, where's your ratio 1/2? And you're going to get 2 answers, right? I think.
Yeah, it's going to be pi over 6 and
5 pi over 6, right? So we usually use the one in the first quadrant. Usually use the one in the first quadrant. Pi over 6, yeah, pi over 6. Yeah, 5 pi over 6 also works, but we usually just use the one in the first quadrant. Okay. If that's your only, if you have multiple answers, pick the one in the first quadrant. So that would be pi over 6, right? So common denominators. So 3 pi over 2, or sorry, pi over 2 is the same thing as 3 pi over 6, right?
where did the 2 go?
What are you talking about?
The 2 times arc sine of 1. 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 2 times arc s
Oh, sorry, the arc, yeah, sorry. So there should be a 2 in front here, right? So we're going to get 3 pi over 6 minus pi over 6, which is 5 pi over 6. Times 2, you're going to get pi over 3, 5 pi over 3. Okay.
You wouldn't multiply it first and then subtract?
You could multiply it first, or you could multiply it last. They both have a 2 in there, so you could factor out a 2 and then subtract them and then multiply. Or you could multiply, so it'd be pi, right? This guy, if you multiplied first, this guy would be pi, and this guy would be pi over 3. You get the same answer, 5 pi over 3. Okay. Letter B. Again, if I try to do this one using U substitution or doing the power rule, it won't work. It won't work. And there's a reason for that. It's because it's one of the arc. It's one of the... It looks like it's going to be arctangent, right? There's no square root at the bottom, and it has a plus. It fits this general shape, this general pattern, I should say. So first thing I always do is rewrite it. Square root of 3, negative 1. So 1a squared plus u squared. Because a is 1, u is x, right? Okay. So that means 1 over a, so 1 over 1, arctangent, u over a, plus c. Well, we don't need a plus c this time because we have bounds. So there we go. So again, I'm going to plug in. So we have arctangent of square root of 3, arctangent of negative 1. Okay. So where is tangent equal to square root of 3?
Pi over 6.
Pi over 6. Pi over 6 and 4 pi over 3, right? But we'll use the one in the first quadrant.
Pi over 3. Oh, no, my bad.
Pi over 3 and, yeah, 4 pi over 3, right? Though both of those would give me pi over 3, but, or sorry, root 3, but we just use the one in the first quadrant. So the one in the first quadrant is pi over 3. Negative 1, where does it give me negative 1?
3 pi over 4.
3 pi over 4, I think, is the first one. It's not in the first quadrant, but it is the first one. So 3 pi over 4. Okay, common denominator is going to be 12. So I get 4 pi over 12 minus 9 pi over 12. So that's negative 5 pi over 12. Okay. The only difference with C and D, oops, wait. Yeah, is that D doesn't have bounds. D doesn't have bounds. C does have bounds. Okay? So let's do D since C is very similar. We'll come back to that one if we have time, but. Okay. Okay, so again, if we tried to use U substitution, this one wouldn't work. So, which one does it match, or which one does it?
Arcsine or arcsecant?
Arcsecant, right? Give me one second, here we go. Arcsecant. Right. Okay. So arcsecant says we got U's and A's. So I'm going to rewrite it with U's and A's. Again, the -1, I'm just going to move to the front. Anytime it's anything other than a 1, just move it to the front. So U is X. What is A going to be here?
-4.
Not -4. It's going to be 2, actually. It's going to be 2 because it's x squared. So how do I make 4? 2 squared. So that's why it's 2. Okay. So we go back up to our thing and says 1 over A. So 1 over 2 times arcsecant, absolute value of U. Well, U is already positive, so it's just going to be X over 2 plus C. Okay. So like I said, the hardest thing is realizing what it is. Oh, this is arcsecant. This is going to be one of them, so I got to go look. Because I'll tell you right now, if you see this, because these problems are mixed up. They don't tell you which one is which on the test. So you'll have a problem like this, and you'll try to do U substitution. It won't work. And you'll try U substitution again. It won't work. It won't work. It won't work. And you're like, what's going on? Why won't it work? Am I doing something wrong? Well, no, it's not one of those problems. Okay, it's not one of those types of problems on there.
Is there an easier way to identify it versus like plugging it in?
So the way I do it is if you have something with a square root on the bottom, right? Because these guys always have square roots on the bottom, except for arctangent. And then there's always a squared and a u squared, right? So if both of these numbers are squares, that kind of gives it away. That kind of gives it away. If you have a problem, and it's 2 plus x squared or something like that, it won't work because 2, you can't square 2, right? There's nothing I can change that would put there to make 2. Won't work. Okay, so that one won't work.
So it's like a 4 plus x squared, then you could do
4 would work, yeah. 4, 9, 16, 25, those numbers definitely would work. Okay, that kind of gives it away. That's what you're doing. And most of the time when you guys see these, they won't have bounds. They won't have bounds. They're just straight like D, problems like D. Okay? They're just problems like that. Okay? Mm-hmm. That's a good question. You probably should. We probably should since there's no value we plugged in there. Yeah, so we're just saying that anything that we plug in there has to be positive. Yeah. You guys, if you see these are the types of problems that I could do a whole practice AP test and only see one, or not even see one. They're just rare. They don't see them a lot. But if you understand what it is, they're easy problems because you're like, oh, that's just an arcsine or arcsecant or blah, 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 you know. So you just look at the 4, A, B, C, D, and see which one matches the best, right? So yeah, these, they don't happen a lot. You won't see them a lot on multiple choice, and you'll only see them on multiple choice. You won't see them on any free response questions. Okay. All right. Okay, let's go to, that's the first half. That was the first part mini lesson. The second one is something called average value. Average value. Okay. What is average value? So average value, is kind of, it's the average area. Okay, it's an average kind of area under the curve. Okay, so if f is integrable, if you can integrate it, if it has an antiderivative over the interval a to b, then this is how you find the average value. So average value is almost identical to what we've been doing. There's just one thing we haven't done, this guy here. That guy here, that's the new part that we haven't, that average value has that every other problem we've done so far hasn't had. Just a fraction. What is the fraction? 1 over top bound minus bottom bound. And you're going to have a fraction in front. And then you just do exactly what you've been doing, right? Exactly what you've been doing. Okay. Okay. Sometimes it's called the mean value theorem of integrals too. Sometimes it's called that. Yeah, go ahead. Okay. So average value is what you usually see it called, but sometimes they'll call it mean value theorem of integrals. We had a mean value theorem of derivatives, but now we have a mean value theorem. Sometimes it's called that. Not always, but sometimes it's called that. So if you see mean value theorem of integrals, it's the same thing as average value. Okay? All right. So the mean value theorem for integrals basically says that if you are finding the area under a curve from A to B, then there is some number, C, between A and B where the function value you use can form a rectangle and has an area equal to the area under the curve. So I'll give you an example. I'll give you just a generic example. Okay, so let's say we have a function. Let's say we have a function from A to B. Okay? And let's say this guy starts here and ends here. All right, so that we have, let's say we're trying to find area under the curve, right? We're trying to find the area under the curve from A to B. That's our job. We've done that before, many times. The difference between what we're doing today, average value theorem and average value formula, is that average value, what that'll do is it creates a rectangle. How tall, in other words, how tall does a rectangle need to be for it to give me the exact same area? How tall would that rectangle need to be? In other words, would this little rectangle have the same area as the green? No, it's not enough, right? So it has to be taller. Would this little rectangle have the same area as the green? No, it's got to be taller, right? Would this rectangle have the same area as the green? We're getting closer, right? If I go too high, would that little rectangle have the same area as the green? No, it's too much, right? So how tall does that rectangle need to be? That's what this tells us. The rectangle needs to be this height to give me the same area as the green. Okay, that's what it tells. That's the explanation, the why behind why we do this. Okay, that's what it tells me. Mm-hmm.
So it gives you the y value?
So it's going to give me, so that C that it talks about is a y value, yeah. Yeah, it says where C is, that's the y value. Mm-hmm. Okay. All right, so we got a couple problems, and then we'll be done. Okay. So here we go. So here we go. Function is negative x squared minus 4x. What is the average value of f from the interval -1 to +1 written in simplest form? So in other words, they want to know how tall. That's what it's going to tell me. If I find this out, it's going to tell me how tall that rectangle needs to be the area. Okay? So here's our formula we're going to use. Again, the only new part is this guy right here. That guy right there. Okay? So let's set this up. So let me write it up here. For average value, you have 1 over b minus a. B is the top bound, a is the lower bound for f of x dx. That's what we're doing here. Okay? So first thing, let's set up all of this. So 1 over, what is the top bound going to be? 1. What's the lower bound going to be? -1. So it's going to be 1 minus -1. That's what's going to be in the front. And then we're going to find area under the curve for our function. So what is the fraction that's going to be in front? 1/2. Or we're divided by 2, right? Same thing as divided by 2. So we have 1 to -1, and then once we do that, you do exactly what you've been doing. Find area under the curve. How do we do that? We got 2 ways. Power rule, U substitution. For this guy over here, what would be easier? Do we need to use U substitution, or will power rule be enough?
Power rule.
Power rule will be enough, yep. Okay. So we're just going to use the power rule. Power rule says, so we have 1/2 in front. Power rule says add 1 to the power, divide by that new power. Add 1, divide by the new power. And we have to evaluate that from 1 to -1. So in other words, we have 1/2 times -x cubed over 3 minus 2x squared from 1 to -1. Okay? One-half goes in front. So first thing I'm going to plug in is 1. -1 cubed divided by 3 minus 2 times 1 squared. -1 cubed divided by 3 minus 2, 1 squared. So I'm going to put a 1 and then a -1. Oops, sorry, no. Both ones. And then -1 over here. Okay? So let's see the first guy. -1 cubed, or 1 cubed is 1 times -1 is -1, so I get -1/3. Minus 1 squared is 1 times 2 is 2. Next one. -1 cubed is -1 times the -1 in front is going to be, this guy is going to be positive. And then this guy is also going to be -2. Because -1 cubed is -1 times the -1 in front, or a negative in front, you're going to have, that's why it's going to be positive. Distribute. I got to distribute the 1/2s now. So I get negative 1/6 minus 1. 1/6 minus 1.
How do we get 1/6 if we multiply two fractions together?
1/2 times 1/3.
Yeah, wouldn't that be 2/3?
No, you go straight across. When you're multiplying fractions, you just multiply straight across. So you multiply the top times the top, bottom times the bottom. So over here, we would get negative 7/6. Over here, we get negative 5/6, just subtracting fractions. Minus a negative, you get negative 2/6, which equals negative 1/3. That's how tall the rectangle would need to be. It's not going to be a very tall rectangle. It's going to go down 1/3 of a unit. Okay. So all of this we've done before. Okay. The only new step was this guy here, which became 1/2. But once you put that fraction in the front, it's everything we've done before. It's nothing new. Okay. All right, so let's go. Let's do a trig one now. We got a trig function now. Average value. So right when I see average value, now average value is not the same as average rate of change. Sometimes I'll say average rate of change. That's not the same. Average value, we use this. Okay. So I have pi over 3 times x dx. The top bound is 9 over 2. The bottom bound is 1 over 2. I got to subtract them. Now I'm ready to roll. What is 9 over 2 minus 1 over 2? 8 over 2, which is 4, right? So it's 1/4.
No, so you're right. You write it that way, and then you would switch.
Okay. Now I got to do area under the curve. Here's my question. That should be at 3. I'm going to have to use U substitution for this. Yeah, why? Which part of this guy is causing me to use a U substitution?
The sine?
The inside. If it was just sine of x, you don't need to. The antiderivative of sine of x is negative cosine of x. But because there's something other than x in here, I have to use U substitution. And that's going to be my U. Okay. So U is going to be the inside, pi over 3 times x. The derivative is just pi over 3 dx. Instead of dividing by pi over 3, I'm going to multiply times the reciprocal. Multiply times the reciprocal. So I get 3 over pi times du equals dx. Okay, so I get 1/4, 9 over 2, 1/2 over 2. Still have sine, but now I have u. With du, or sorry, with dx, I have 3 over pi times du. Only got u's. And then this guy is a constant. That guy is a coefficient. I'm going to move that guy to the front. So I have 1/4 times 3 over pi. The antiderivative of sine is negative cosine. And I have to evaluate that from 9/2 to 1/2. Okay, so I'm going to get 3/4 pi times negative cosine.
Okay. How was the last day I did this one? That's
U I got to put back in. Pi over 3 times
yeah, 'cause you
x.
gotta go into both the 7 and the x. Well, 3, 4, 5, 8, 10. Go. You just gotta do the 7 from 7 from 7.
Okay,
If you're in strict.
I got to plug in 9/2
No, you
first.
don't distribute at all. You can just leave it. Yeah, we don't care.
So pi over 3 times 9/2. And then I'm going to plug in 1/2. Pi over 3 times 1/2.
Yeah, okay. And then the last thing is just this guy right here. I have
Okay.
to replace the y with
So the 9 and the 3 will cancel out. That will be a 3. Over here, nothing cancels out. So really,
oh, yeah, sorry.
It's 3/2 of pi.
it's 3 pi over 2, right? 3/2 pi. It's 3/2 pi. So I go to my
Exactly.
neon sheet. So it's cosine of 3 pi over 2. That's what it is. So cosine of 3 pi over 2 is 0. Cosine of 3 pi over 2 is 0. Anything times 0 is just 0.
Which one do you think looks better?
Okay, now the next one. 3 times divided by 4 pi.
Yeah, I think you know that.
This one, I can't divide anything. It's just going to be pi over 6. 1 pi over 6.
You know this simple? That's a little tough.
So I go back and find what is cosine.
This one, you know how to get rid of that, right? Use that.
Square root of 3/2.
Square root of 3/2, right? Square root of 3/2. Okay. So multiply, I'm going to get negative in front, and I'm going to get negative 3 square root of 3 over 8 pi.
And that just be positive then?
And then that would just be positive. 3, 8 pi. Okay. All right. Okay. Let's see, 4, I think that's it. 4, we got one more left and we're done. So tomorrow we'll do some practice. So we have enough time to do this one. And then the one we skipped, if we don't have time, I'll do that one and put it in the notes. So if you want to copy it later. Okay, so average value. Okay. What's the lower bound? What's the upper bound?
The lower bound is 1, the upper bound is 4.
Good.
Okay.
4 minus 1, right?
Real quick for you. Does that make sense or not? You can say no.
So 1/3.
This stuff. The radicals. You sure?
That's where the new stuff ends. After that, we're just going to do what we've always done.
This part was confusing.
So to find the antiderivative of this guy, to find area under the curve for this guy, can I use the regular power rule? No. I'm going to have to use U substitution. Okay. Well, the 6, you can actually move the 6 to the front. So 6 divided by 3 would be 2, right? So it would be 2. So what would U be on this one?
Natural log of u for x minus 7.
It would be x minus 7, right? It would be this guy right here, x minus 7. So that's 1 dx divide by 1. 1 du equals dx. Move it back in. What's the antiderivative of 1 over x or 1 over u? Natural log. That's where natural log comes in. Yep. So you have 2 times the natural log of u, and then we have to evaluate that from 4 to 1. Okay. 2 times the natural log. So remember, this has to be positive here. So I'm going to put the bars around it. X minus 7. So if I were to plug in a number smaller than 7, it would have to be the answer would have to be positive. So it just depends on what numbers you're going to plug in. If you're going to plug in numbers 7 or bigger, you're okay. If you're going to plug in numbers smaller than 7, then you're going to have to put the bars. Okay. All right, so let me plug in these two guys. So we get 2 in front of both. And then we get natural log of x, 4 minus 7. Natural log of 1 minus 7. Okay. So we get 2 times the natural log of 3, right? Because it's going to be negative 3, but absolute value is positive 3. Minus 2 times the natural log of 6, right? Now, without a calculator, I don't know what the natural log of 3 is, and I don't know what the natural log of 6 is. That's why it said. For natural logs, just simplest form. Simplest form. That's as far as I can go. I can't simplify natural log of 3, and I can't simplify the natural log of 6. I mean, you could go farther. Since they both have 2's, using log properties, that means this guy is actually squared and this guy is actually squared. You can do that. So it's really 3 squared minus 6 squared. So it's really the natural log of 9 minus the natural log of 36. And then you can use another log property to say, instead of subtraction, you use division. And then I reduce that. It would be 1/4. The reason I show you that is because if you see this on a multiple choice question, they probably have this guy as the answer. Natural log of 1/4. Okay? If it's free response, I'm okay with this answer. You don't have to do the extra steps. But I get this question every year. Let's say we have one of these on a test, and one of the answers is natural log of 1/4. I don't know how they got there. Okay? I can't help you on the test, so that's why. Free response answer, first one's okay. Multiple choice answer, probably the second one. Okay. All right, and that was it. Like I said, that's the end of the chapter. Okay? So we'll start reviewing